Now that we have Mendel's laws, we can use tools, probability tools, to help us predict the possible outcomes for genetic crosses. One of these tools that we're going to use is a Punnett square. A Punnett square is a table listing all possible genotypes resulting from a cross. All possible sperm genotypes are going to be lined up on one side. All possible egg genotypes are going to be lined up on the other side. All possible zygote genotypes will be placed within the squares. So here's an example of what that's going to look like. Here we have a Punnett square where we're looking at the probability of attached versus detached earlobes. This is going to allow us to calculate the probability of genotypes and phenotypes among the offspring. The Punnett square on the next slide is going to show a 50-50 cross for attached versus detached earlobes. So here what we have is the parents have the parents are going to be heterozygous for this trait. This individual is going to have a genotype of a heterozygous genotype, meaning that they have big E, little e. They have the dominant trait and the recessive trait. Same with this individual over here. They're heterozygous for this trait, meaning that they have big E, little e. They have the dominant trait and then also the recessive trait. Now, when we cross these individuals to see what their offspring might be, we're going to line up their genotypes along the top and along the side. This individual, if this individual receives the dominant genotype or the dominant allele from the mother and the dominant allele from the father, they're going to have a genotype that is big E, big E. If they receive a genotype that is, or if they have the genotype where they receive a recessive allele from their mother and a dominant allele from their father, their genotype is going to be big E, little e, or heterozygous. If they receive the recessive allele from their father and the dominant allele from their mother, they are also going to be big E, little e, in other words, heterozygous. If they receive both recessive alleles from their parents, they're going to be little e, or homozygous for the recessive trait. So the chance of their offspring inheriting both alleles, both dominant E alleles, is going to be a 1 in 4 chance. The chance of them inheriting the dominant allele from their father and the recessive allele from their mother, 1 in 4 chance. The chance, or the odds that they're going to inherit the recessive allele from their father and the dominant allele from the mother, 1 in 4 chance. The odds that they're going to inherit the recessive alleles from both parents are also going to be 1 in 4. Now, here's the interesting thing. Just because their genotype is going to be 1 in 4, that does not necessarily mean their phenotype will be. Because if we have if the dominant trait is going to be having detached earlobes, what is going to be the probability that the individual will have detached earlobes? That would be 3 out of 4. Because these are detached, these are detached, these are detached. Anytime we have a heterozygous individual, or we have where they're homozygous for the dominant trait, they will show the dominant trait. Only an individual who is homozygous for the recessive trait is going to show the recessive trait. So only this individual here is going to have the attached earlobes. So that is sort of how we use Punnett squares. We will go into great detail with Punnett squares when we start practicing. When we start practicing in our discussion groups. So please, if you have any questions about Punnett squares and how they work, join us for our live discussion times, and I guarantee you we will do a lot of practice sets with Punnett squares.